let's graph. I'm going to graph this asymptote. I'm going to graph this asymptote. I'm going to plot this point, and I'm going to plot this point. And then we'll come back to the chart. First asymptote is x equals -1. The other asymptote is a slant asymptote when x is 0, y is -2. And when y is 0, x is 2. Y equals x minus 2. Now I will plot 0, 0. And I will plot -3, -6.75. 2, 3, 4, 5, 6, 7. I'm going to extend my lines here. And the vertical asymptote. Oh, I didn't mean that. Good. Now I'm ready to read my chart. Ready? Okay. From approaching the slant asymptote, it will be increasing, opening down to this point of local max. From approaching the slant asymptote, it will be increasing to this maximum point. At this point, it will start decreasing. It decreases, still opening downward, approaching the vertical asymptote on the left-hand side. On the other side, it's coming from on the right-hand side of the vertical asymptote from -infinity, approaching the point of inflection. Increasing and opening downward. This is a point of inflection. It will change concavity. This is not a max min, it's an inflection point 0, 0. Change concavity and approaching infinity towards the slant asymptote. Very good question. Excellent question. The slant asymptote, like the horizontal asymptote, talks about the trend at infinity. So I should be graphing, only don't erase anything, please. So all that I care about the slant asymptote is this piece, the piece at infinity, in this case -infinity, and this piece at infinity. Between this point and this point, the slant asymptote shouldn't even be there. It doesn't exist. It has no meaning. But I can graph a line by showing you this piece and this piece. So I have to graph the whole thing, which means the function can cross the slant asymptote. The only asymptote, even a horizontal one, the only asymptote that the function will never cross, it's an excellent question, is which one? Exactly. This function can never cross this or slant. So I can give an example of that. Very good question. So something like this. I didn't mean that. I meant this. And no, I want to give another example. That's not crossing this. I'm going to just say this. Okay, so a function can do this.
cross it and not cross
It can cross. It can cross a horizontal asymptote. No, here I didn't give a good example.
No,
It
no,
cannot
I'm saying-
it cannot have a horizontal asymptote here and another horizontal asymptote there. That's not possible.
it. You know, the second option.
Oh, okay.
Crossed and then it didn't cross.
Right, because it eventually has to approach the horizontal asymptote. It has no choice. So eventually it has to approach it. It cannot do this. So eventually we'll get to 0 because I chose the horizontal asymptote y equals 0. But if you see here, it's crossing it. But this asymptote has meaning only here and here. The rest of the time, it doesn't mean anything. It's only saying that the function at infinity it approaches, at a negative infinity approaches. It doesn't mean anything in between. So now if you want with the graphing calculator, go to y equals and clear, and the function is x to the third and divided by, in parentheses, x plus 1 to the second. Oh, of course, I always do that. Thank you. Thank you. Okay, I need x minus 1 minus 2. The graphing calculator is not as wise as you are. And it will not graph the, I think the software will not. I used it for something else, so I have to change to the standard viewing window. And let's see what happens. Here's our function. And here's again. And now here comes y equals x minus 2. And we know that this is the inflection point. We know it's a flat cross. We know that this is the maximum. Now we don't need the calculator to determine the maximum because we already did. It's negative 6.75. And we know everything else. We just graphed it with the graphing calculator to double check our work, but there is no need for that.
I have a question.
Yes?
It's just a silly question, but like when you have this thing asymptote and when it doesn't cross, when it just approaches it, will it infinitely approach it?
Absolutely.
So it would never touch them?
No. We like to say eventually it may. It's like a horizontal asymptote or a vertical one. Very good. Any questions for me? Any questions? Okay. Remember related rates from chapter 3? So this is kind of how can after, oh yeah, it's 12 and 13. It's 13. Okay. How can, I'm sorry, my question here is, sorry. In chapter 3 we had related rates. Did I start it? No? Yes, I did. So in chapter 3 we had related rates. In chapter 4 we have something which I think it's easier to handle. It's called optimization problems. Algebra is part of math. Calculus is part of math. Differential equations, trig, geometry. This is a huge research and part of math, optimization. Finding max and min of functions. That's what it means. Finding optimum, max, min. Okay. So I selected 4 problems to go over. Of course, we can say we want to choose ourselves, and you can. So they are all on page 331, or we start with these. Okay. Yes, they can get involving depending on a lot of things, depending on the problem, depending on what we are trying to do, and so on and so forth. So after this section, we have the last one in which I promised we will be able to solve any equation you want. Any equation. Just any equation. Even 1/3 x equals sine x. Even x squared, x to the 5th minus x plus 1 equals 0. Any equation with any precision that you want. Which we were never able to do without calculus. Beyond second degree, we don't have any rules. If it's not factorable, I can't solve. I have to use a calculator, right? Okay, so let's stick with this. And on Wednesday, we're going to finish this chapter, and on Monday, I would like to review for the test. Okay? Okay. I'm hoping. Yes. Well, it depends on how fast we can. Give the max and the min distance. So problem 1. So this is 4.7 optimization. Okay. Give the maximum and the minimum distance from the straight line, 3x plus y equals 6, to the origin on the interval 0, 2. I have no idea what this means before I look at the graph. And I will graph 3x plus y equals 6 when x is 0, y is 6. When y is 0, x is 2. So this is the line in question. So this is 3x plus y equals 6. So they are telling us between 0 and 2. So for any x between 0 and 2, find the minimum and find also the maximum distance from the straight line. So in order to find a max or a min, because that's what optimization is all about, I have to have what? I have to have a function. I will not be able to find a minimum or a maximum if I don't have a function. So that's my first step. So what will be the function in this case? Just name it. We don't know what it is right now, but just say the function that I have to find its minimum and its maximum for is the, just read the text one more time with the question. Is the, exactly. So the function that I have to determine or create will represent a distance between the origin and the graph of 3x plus y equals 6. As in the past, I cannot pick a point. That is known. I have to pick a point. Then I'm going to say is x comma. Any point you want, I'm going to call it P, but I need to determine its y coordinate. I picked x to be x, and then y coordinate will be, right? And what is our f of x in this case?
6 minus 3x.
Exactly. That's the y. If the point is on the line, it's x and y have to verify this equation. So then y will be negative 3x plus 6. Excellent. So I have the point, P, and I have the origin. So this is the distance. I'm not going to call it D, I'm going to call it F. So distance equals F of X. And now I have 2 points. Anyone remembers how to determine the distance between 2 points? Square root. The square root of x2 minus x1, everything squared, plus y2 minus y1, everything squared. In our case, this is my x1, this is my y1, or if you want, it's even better. This is my x2 and this is my y2, and this is 0, 0, x1, y1. So then our function would be the square root of x2 minus x1, because this is 0, 0. x2 minus x1 squared will be x squared, plus y2 minus y1, everything squared. Now I can find max and possibly min. because I have a function. And the function is x squared plus negative 3x plus 6, everything squared. How do I find the maximum or the minimum? What do I have to determine first? When we determine for this function, its max and min. What did we have to find? What did we find first? How did I know that this was a max min? Yes, I have to find the derivative and I have to find critical numbers. Very good. So f prime of x equals, I need to differentiate this function. 1 over 2, the square root of x squared plus negative 3x plus 6 squared times, yes, the inner function prime, very good, 2x plus 2 times negative 3x plus 6 times, exactly, times negative 3. Very good. So then, I'm going to write it one more time. F prime of x equals 2x minus 6 times negative 3x, it's positive 18x, and minus 6 times 6, negative 36. Allow me 1 second to check this, make sure this is correct. So we had 2x, 2 times negative 3x, yes, correct. So 2x, so this is negative 6 times negative 3x is positive 18, and negative 6 times 6, negative 36. Perfect. Combine like terms. So 20x minus 36 over 2 square root of x squared plus negative 3x plus 6 squared. And I will take out a 2 and simplify it. So this is 10x minus 18 over the square root. Okay, therefore, what is the critical number? So 10x minus 18 equals 0 means 18 divided by 10. I will simplify by 2. So x equals 9/5. I have no idea what 9/5 is going to give me. What is the domain of this function? I have it right here. I am only asked to look at 0 to 2. And 9/5 has to be between 0 and 2. Okay, so it's 0. So here's the first derivative. I want to study its sign. So what type of number is this? What is the sign of this? What is the sign of the denominator? Always positive. It's a square root. So I'm only going to study the sign of this. At 0 is negative. At 2, 20 minus 18 is positive. So then I'm going to plug in 0 in the function, 9/5 in the function, and 2 because I need these 3 values. So where is my function? This is my function. So let's plug it in. So in y equals, clear. So the top is the square root, bless you, x squared plus, in parentheses, negative 3x plus 6, everything squared. And I want second table, and I want 0, 9/5, and 2. 0, 9 divided by 5, and 2. Okay, so I go to my chart. and I put in the values. So this is 6, this is 1.9, and a 2 is 2. From 6 to 1.9, the function appears to decrease. Is this supported by the sign of the first derivative? From 1.9 to 2, the function is this supported by the sign of the first derivative? So what do I conclude about max? And what do I conclude about min?
There could be a max.
There is a max.
Really?
Yes. So first of all, what is 9/5 and comma 1.9? What type of point is this? Absolute minimum. It's local. I should write local, but it's both. Good. So what is the maximum? So the minimum is 9/5 comma 1.9. And what is the maximum distance? You already said it. Yes. So 0 comma 6 is absolute max. So coming back to the graph, it's very clear. So 9.5, 1.9. So 1.9 should be somewhere here. So this is the point of minimum distance, and this is the point of the maximum distance. So the maximum possible distance from 0 to the line on the interval 0, 2 is here at 0. The maximum distance is 6 units. The minimum distance between the origin and the line on the interval 0 to 2 is this point right here. That's the minimum distance. And that's the maximum distance. Any questions? Yes, please. Thomas?
Is it okay if you, like, because let's say you want to find the local min and local max, right? So you know that the derivative at like the x is 0. So is it okay
The derivative of x
that
is
at like the point, the local max must be like 0? So like say I have a function, right? So the derivative of f of x at x equal to some value a must equal to 0. So you can try to solve for a.
that's what we did. But backwards. We had the derivative, we said we had the function, we differentiated the function. We got the derivative when we set it equal to 0. Because of that reason. Exactly what you just said. At a max or a min, the derivative has to be 0. But I need the function and I need its derivative. And then I will set it equal to 0. Is that what you meant?
Yeah.
Yes, that's exactly what we're doing.